is relatively good. How do I know that? Because I see it's green. It says it's extremely good, and there is this kind of a value which is very close to 1. So it gives me this good feeling that maybe the model that I build is very, very good. But it's not enough. Let's jump into this visualization that we have as part of the Amazon Machine Learning console that shows us this interesting visualization. So this is a binary classification. Binary meaning, will I send it, will it click, or not? These are the two options. So these are the people that I'm going to send my campaign to them, and these are the people that I'm not going to send the campaign. How do I know that? I took the data, I split it to 70% which I did a training, and 30% which I didn't see. So the model never learned, was never trained on this 30%, and I'm testing this model on this data. And it gives me a prediction how good it's going to work on data that it didn't see because it didn't see this data. And you can see that I have this yellow area. The yellow area is people that I send them the campaign, and they clicked on that. How do I know they clicked? Because historical data. These are the gray area is, again, people I didn't send it, and if I did send them, they will not click. So it's a good decision not to send them. But we also have these two areas. These are the false positive. That is, I said yes, and they were not. And this is the false negative. I said no, but they were yes. So these are missed opportunities people could buy, and I didn't send it to them. And this is people that I just bothered with the prediction that a campaign they didn't care about. So what can we do with that? We can play with this number. So I can change the values. And this is a business decision. I can decide that I want to send to more people and risk annoying more people, but missing less opportunities. Or I want to be friendly and send only to very few people, but missing a lot of my opportunities. Okay? This is a business decision that I can do. And if you look on this area, you can see how nicely it is changing. So I can get less false negative. Now I can get fewer false negative, but of course I'm getting more false positive. Okay? It's obvious how it's happening. You can also notice that the overall prediction is very high. So it's 90% anyway. So it doesn't change the model. It doesn't change the accuracy. It does change two important aspects, which we call, again, you can see it here, they are called recall and precision. So when you are getting a task from the business to build a machine learning model, and they tell you, I want a 90% accurate model, tell them, no, you need to give me more specific numbers like recall and precision, because it's very easy to do a 90% accurate model by saying no to everybody, because most of the people are no, they're not going to click on that. So if you want to really reach our customers and touch them in the right way, ask them, what is the recall? What is a recall? Recall is how many of the people that are going to buy my product, are going to click on my ad, are going to get the mortgage, I'm hitting and I'm finding. So now I'm getting more. You can see the recall number goes up to 65%. So maybe this is the definition of my business. They want to say, no, I want 80% recall, so I can go up to 80%. At the same time, I'm killing my precision. So what is precision? So if I'm sending you the promotion, how likely it is that you're actually going to buy the product? So you need to get those two numbers, how precise it is and how, what is the recall. And then you can tune your model and also see if the model is good enough. If it's not good enough, let's go and get more data and train again and so on, change the parameters to improve the overall performance of this model, again, based on the recall and the precision that we are getting for the business. Okay. 15? No? Okay. So I will jump to the last example.
I have a question for you.
Mm-hmm.
For machine learning algorithms, are being done randomly on the background? Is it using ensemble learning to that?
So the question is, what is behind the scene of this Amazon machine learning service? Are we using ensemble? Are we using parameters optimization? Whatever we are doing there. So again, this is our secret sauce. You have no control over that. We are doing a good job. It's running in large scale inside of Amazon and other customers. You don't have control over that. But if you need to do more, this is exactly the next example I want to show. So you can also build your own model using your own data scientists. So most of the data scientists, what they want to have control. They ask questions like, can we do ensemble? Can we change the parameters? Can we use this library? I really like this Python library. Can I use that? So with Amazon Machine Learning, you cannot do that. We are doing everything for you. This is more designed for the long tail. People with less, what they want to automate, they want to have many models and so on. If you want to have specific models like recommendation engine, you will use what I'm going to demo now, which is this example. So this is still Zeppelin, so the same driver, but now I will quickly run you through for this notebook. This notebook is part of a blog post that I wrote about a year ago in the AWS Big Data blog. So if you search AWS Big Data blog and either my name, Guy, or Recommender and Zeppelin, you will find these code samples. But what I'm doing here, as you can see, loading the data from S3, remember from your data lake. I can look at the data. This is how it looks. So there is the name of the movie and the year and some ID. I can count how many items do I have. So I have 10 million recommendations, 70,000 users, 10,000 movies, and so on. So it's a sizely data set. Here you can see that I need to do this kind of heavy lifting of splitting the data. In the Amazon Machine Learning, I didn't need to do that. I called the model and it built it for me. But here you need to be more cautious and do it and do this kind of a split. Then you will need to define what is your valuation function. You don't have this visualization automatic out of the box. But again, you can copy paste it from the internet. There are many of them already. You are doing your own training. So this is the place where you can go and decide what are the parameters, what are models you want to use. Here I'm using a library called ALS, which is implementation in Spark ML of collaborative filtering. Again, a very popular system to take those ranking of users and movies or music and create this kind of recommendation for us. You need to understand what you are doing. Okay, this is not as simple as I did before. This is a bit more advanced, but it's giving you much more control over what you want. Then we can quickly, again, we are out of time. We're creating a model, blah, blah, blah. Let's jump into recommendation. So here is, I'm calling the recommender, and I'm asking it to give me my recommendation. So this is the best model is what I trained, and I ask it predict, and I get this prediction. Okay, this is the movie that I got a recommendation for. Then I say, no, I want only comedy movies because this is what I like. So I can go and load the movie data with all the genres and everything like that. This is what I'm doing here. You can see that I have this movie is a drama, and this movie is a comedy and a crime drama and a thriller and so on. And then I can do the same prediction by first filtering. Again, this is the power of Scala, that you can have in one line add the ability to filter on specific candidates, like the candidates that the match is with the word comedy in the genre description. And then I get my prediction. And this time I'm getting these movies. So Pulp Fiction, Dr. Strangelove, it's a great movie if you didn't see that, Monty Python, and so on. Again, the comedy movies. Again, I'm sorry for rushing through the last example, but Girish is a very determined person, and I will kick me out of the stage in a second. So let's couple of minutes for a question, or?
We have 3-4 minutes.
How many?
3 to 4 minutes.
3-4 minutes. So let's try to answer questions. Yes, please. So the question is how easy it is to tweak the models that we give you. So it depends on what model you are using. So if you're using, again, it's open source, most of the stuff. Amazon Machine Learning is not open source, it's a closed source, it's a managed service. It's our secret source. We're always evolving that and improving that and giving more capabilities. What you see is what you get. If you have to do it yourself, remember I mentioned this selection. So Amazon Machine Learning is designed for scale, for automation, and if you need to do it manually, like those tweaks that I did with ALS, then you can do whatever you want. This is just Python code, Scala code, whatever the library that you like to use, scikit-learn or whatever, it's up to you. We are not helping there in any way other than giving you infrastructure and so on.
So if I want to use my own models like the scikit-learn,
Scikit-learn?
I won't be using the ML, Amazon ML.
No, so if you want to use, again, think of Amazon Machine Learning as another library that you can derive from your environment, Zeppelin, Jupyter, and so on. It gives some capabilities like I don't need to think about my features. I can train on gigabytes of data. So here, you can run as much as cluster that you have. So if you have 100 gigabytes of data, maybe you need a bigger cluster. If you're using Amazon Machine Learning, again, we are provisioning the cluster based on the data sets that you have. Thousands of attributes and so on. And we are hosting it for you. So once you finish building the model, you can go and immediately do this lookups like I did from my flight prediction. Still, some people, many people, especially if you are already data scientist and you already have some libraries that you like and you are missing this functionality, or you don't have this functionality like this collaborative filtering. We don't have collaborative filtering in Amazon Machine Learning, and you have to have something like the example I just showed, briefly showed regarding train your own models. Another question? How do we do real-time prediction in this sense?
Which you have the flight thing. The flight real-time prediction thing. So how is it running? Where is it running? Lambda?
Right. So the question is where do we have the real-time part of it running? So to remind you, we have the training data, which is not running in real time. It's something that's running in batches every hour, every week, every day. It's up to you. And then we are taking this model and we are saving it to S3, for example, and then we need to load it to something that will do this kind of a real-time front-end prediction. So where do you host it? First, if you're using Amazon Machine Learning, we do the hosting for you, we do the scaling for you, and so on. If you want to do it yourself, you can do it yourself using things like Lambda, as I mentioned. You can just have a Lambda function with your Python library that you like. It will load the model from S3, where you saved it from your training data, and serve it. Lambda, containers, the same idea. You have a container with your favorite Python library, and then load the data, load the model from S3.
So the Amazon ML can actually host it for you. That's
Yes, you can host and serve it from the cloud, from Lambda, from ECS, from your EC2, even from the Spark cluster. So Spark cluster have something called Job Server, and you can use that to serve from there. Again, it depends on the requirements of your real time, how many TPS that you need, how often do you change the model, how big is the model, what kind of library do you use there. All this kind will define where is the best way to serve those models from.
Guys, just one quick announcement. The lunch is going to be served at 1:30 upstairs. Okay. For half an hour, we are going to have a voice-enabled app session by Olivier. Right. It's a brilliant and very entertaining session. Please do stay back. And Guy, you can continue till Olivier switches the room.
Okay.
So I think we have room for probably one or two more questions.
Until Oliver and the sexy Alexa is coming and kick me away. I will throw the mic. At the end, the last row.
Hi. Since you mentioned like Amazon EMR is purely based on public distribution of various Apache libraries. So how frequently it is getting updated? Because as a developer, I will be more concerned about writing the business logic in the back end. Let me say
Can you ask a bit slower? English is not my first language, and I hard to understand.
Fine. So you mentioned this. EMR is purely running behind on libraries like open source libraries. Mm-hmm. So how frequently it is getting updated on the EMR service? Because the reason as a developer, I will be more concerned on writing the core logic. So let me say this is the open source. There will be thousands of contributors to contributing the each and every framework. Either it could be a Zeppelin or Hadoop, Hive or Spark 2.0, whatever it is. So how frequently, how are you the Amazon managing the new distributions? new patch releases?
Let me try to see if I understood your question. How much do you need to use Amazon Machine Learning? How much you can use something else, open source, and how do we merge them together in some for your system? This is more or less what you wanted to understand?
Basically, we are using Spark ML and R also. So, like,
Right.
I want to understand. Let me say, like, my model is capable enough to directly can be migrated to Amazon ML. Suppose if I have stored using libraries something like PML, predictive modeling markup language.
So it's a great question because, again, this is the type of request that we are looking for. So we are looking on ways to make it even easier. So I don't know if you know that, but machine learning is not used a lot. Maybe in this room, we have a very good density of people using machine learning, but it's not that popular, and most of our customers are still not there. And we want to make it much easier for you. Again, this kind of example, how can we make it easier for you to start an experiment with one library, and then maybe we can help and host it in our environment, import it into Amazon Machine Learning. These kind of ideas are great ideas, and we want to get and hear more of them. Currently, what you have, again, you have a managed service like Amazon Machine Learning. You have do it yourself, and you have to do it yourself. We are not converging those worlds together, basically because it's two types of people. If you think about it, the data scientists, they like to have their own tools, the one that they are used to have, the one that they were trained on, R, and Spark ML, and Python, and TensorFlow, and MXNet, and hundreds of those very powerful, very interesting libraries, which they love and they know how to use. On the other hand, we have the long tail. We have many developers, analysts, they don't understand those libraries well enough, and they are looking for us to help them. So we have the data. In Redshift, in S3, we have a lot of data, and we want to try to build models for that. Weather prediction, flight delay prediction, whatever is the problem, the business problem you want to solve. So this is what Amazon Machine Learning is doing today. So make it this kind of a long tail problems. The heavy, hard problems where data scientists are working, they will use their own tools. There's no bridge between them. But it's a great idea, and we need to have this bridge.
Thank you. Thanks.
Another question while Alexa is turning around?
Hello? Yeah.
Okay. So again, Alexa, this is the reason why we are all here. And I challenged Oliver to do something different today. I will stay and look and see if he's actually meet this challenge. It's going to be fun. Thank you.